Dear students, today we are going to solve some numerical problems on DC electricity based on Kirchhoff's laws, meter bridge and Wheatstone bridge principles. Now, at first we discuss the helping tips. There are two Kirchhoff's laws. First one is Kirchhoff's current law, that is KCL. According to his algebraic sum of all the currents at a junction of a closed circuit is 0, that is sigma I is 0. And second one is Kirchhoff's voltage law, which can be abbreviated as KVL. According to KVL, in a closed loop of a circuit, sigma EMF is equal to sigma IR, means algebraic sum of all the electromotive forces is equal to algebraic sum of the product of all currents and resistances. Next, balanced condition of Wheatstone bridge. This is the circuit of Wheatstone bridge. If by varying the variable resistance R, we make the deflection in the galvanometer 0, that is current in the galvanometer is 0, then the Wheatstone bridge is said to be balanced and its condition is P upon Q. P upon Q is equal to R upon S. Next, meter bridge. Meter bridge is also a balanced Wheatstone bridge, or meter bridge is also a Wheatstone bridge when it is balanced by moving the jockey or slider key to make null deflection in the galvanometer. Then this resistance upon this resistance is equal to resistance of wire from this point to this point upon resistance of wire from this point to this point. Because this wire is, meter bridge wire is of 100 cm length, therefore P upon Q will be equal to L1 upon L2, which is 100 minus L1. So for meter bridge, balanced meter bridge, P upon Q is equal to L1 upon 100 minus L1. Now, in series combination of resistances, resultant resistance R in series is equal to R1 plus R2 plus R3 and so on. And in parallel, resultant resistance is given by the relation 1 upon R parallel is equal to 1 upon R1 plus 1 upon R2 plus 1 upon ... 1 upon Rn. Next, we take some numerical problems. First question is, in the given diagram circuit, find potential difference between points A and B. Here, this is the given diagram or circuit, electrical circuit, in which we have to find the potential difference between points A and B, that is between point and point A and point B. Now, the upper branch, this has resistance at 2 ohm and 3 ohm in series, that is resultant will be 5 ohm. Similarly, the lower branch has 3 ohm plus 2 ohm in series, that is 5 ohm. Now, both the upper and lower branches being of equal resistance, this current 2 ampere will be equally divided into upper and lower branches. Therefore, as upper and lower branches have each have 5 ohm resistance. Therefore, current I1 will be equal to current I2, which is I by 2, means 2 by 2 is equal to 1 ampere. Now, D minus B minus B D minus B A will be BD minus B. B means I2 into 3. So 3 I2 and BD minus BA means 2 I1. I1 I2 are equal. Therefore we can write it as BD minus BB minus BD plus BA. This gives BA minus B is equal to 3 into 1 minus 2 into 1 means 1 volt. So the potential difference between points A and B will be 1 volt. Next question 2. In the given circuit, find equivalent resistance between points A and B. We have to find the resultant resistance between points A and B in this circuit. Now solution. Here in this branch 3 ohm plus 7 ohm or 3 ohm and 7 ohm resistances are in series. Therefore 7 plus 3 10 ohm is in parallel with this 10 ohm. So the resultant between A and C will be 1 upon 10 plus 1 upon 10 means 2 upon 10, which is 1 upon 5. So if RAC is the resultant resistance between A and C, then 1 upon RAC will be equal to 1 upon 10 this plus 1 upon this plus this 3 plus 7 means 2 upon 10, which is 1 upon 5. Therefore R between A and C will be 5 ohm. Now this 5 ohm is in series with this 5 ohm. 5 plus 5 becomes 10. Now this 10 ohm and this 10 ohm both are in parallel. Therefore 1 upon RAB will be equal to 1 upon 10 plus these two are in series. 5 plus 5 means 10. 1 upon 10, this is 2 upon 10, which is 1 upon 5. This gives R between A and B as 5 ohm. Third question is, in the given circuit, find the ratio of heats H1, H2 and H3. Here H1 is heat developed in resistance R, H2 is heat developed in resistance 2R, and H3 is heat developed in resistance 3R. Now solution. Because resistances R and 2 are in parallel and in parallel voltage is same, therefore voltage between potential difference between A and B will be equal to I1 into R, this voltage, which is equal to I2 into this resistance 2R. RR cancels, therefore I1 becomes 2 I2, that is I2 will be equal to 1 by 2 means 0.5 I1. Now desired heat ratio will be H1 is to H2 is to H3 equal to, now H1 is to H2 is to H3 will be I square I1 square RT is to I2 square 2RT 2 RT is to I square, here I square 3 by 2 RT. Time is same is, therefore can be cancelled. Ratio will be 1 H2 H3. H1 is I1 square RT. H2 is I2 square into 2R into T. H2 I3 is or I square into 3 by 2 R into T. Here R and T are common to all, therefore can be cancelled. We get I1 square is to 2 I2 square, 2 I2 square is to 3 by 2 I square. Now I1 square is to 2, I2 is I1 by 2 square is to 3 by 2, and I2 is I1 plus I2 square. So this is I1 square is to 2 I1 square by 4 is to 3 by 2, and this is I is equal to I1 plus I2, I1 plus 0.5, I1 means 1.5 I1, 3 by 2 into 1 by 3 or 3 by 2 I1, 3 by 2 I1 whole square. Again I1 square are common, can be cancelled. So the ratio is 1 is to 2 by 4 means 1 by 2 is to 3 by 2 into 9 by 4. Now the ratio may be written as multiplying all of these with 8, we get 8 is to 2, sorry, 8 is to 4 is to 27. Therefore the desired ratio will be 8 is to 4 is to 27. 8 is to 4 is to 8 is to 4 is to 27. Now fourth question is, in the given circuit find the currents I1 and I2. This is the circuit diagram. Now come to the solution. Because resistances 12 ohm and 4 ohm are in parallel, potential difference will be same. Therefore VAB will be equal to I1 R1. I1 R1 is equal to I2 R2. This gives I1 into 12 is equal to I2 into 4, which gives I2 is equal to 3 I1. Now equivalent resistance of these two will be in parallel. 1 upon RAB is equal to 1 upon 12 plus 1 upon 4, which is LCM is 12. 1 plus 3 means 4 upon 12, which is 1 by 3, gives RAB is equal to 3 ohm. Now current in the circuit will be I is equal to E upon RAB plus R3 plus internal resistance. Putting the values, 12 upon 3 plus 2 plus 1 means 2 ampere. Now from KCL at point A, I will be equal to I1 plus I2, which is I1, I2 is 3 I1, so this is 4 I1, which gives I1 is equal to I by 4. I is 2 ampere, therefore 2 by 4. which is 0.5 ampere. 0.5 ampere. Now I2 will be 3 I1, 3 into I1 is 0.5 ampere, therefore I2 will be 1.5. Next question number 5. In the given circuit, find the potential difference between points A and B. This is point A and this is point B. Current in the circuit is given to be 2 ampere. Solution. Because the upper branch is of 2 plus 3 means 5 ohm resistance, and lower branch is also of 3 plus 2 means 5 ohm resistance. Therefore, equal currents will be flowing in upper and lower branches. That is, I1 will be equal to I2 is equal to I by 2, because upper and lower branches are of 5 ohm resistance, equal resistance, and I is 2 ampere, therefore I1 and I2 will be 2 upon 2 means 1 ampere each. Therefore, VA minus V will be equal to VA minus V will be equal to I1 into this resistance 2. I1 is 1 into 2 means 2 volt. Next question number 6. In the given circuit, find resultant resistance between A and B. Solution. Here, resistance 2 upon 3 is equal to 4 upon 6. That is, P upon Q is equal to R upon S. So, the given circuit is a balanced Wheatstone bridge, because 2 upon 3 is equal to 4 upon 6. Hence, the given circuit is a balanced Wheatstone bridge circuit. Hence, 7 ohm resistance will be inactive, means short circuited. So, 2 ohm plus 3 ohm of upper branch and 4 ohm plus 6 ohm are of lower branch will be in parallel, and 1 upon R AB will be equal to 1 upon 2 plus 3 plus 1 upon 4 plus 6, that is 1 upon 5 plus 1 upon 10, that is LCM is 3, 2 plus 1, that is 3 upon 10. So, resultant resistance between A and B will be equal to 10 upon 3 ohms. Question 7. In the following circuit, find potential difference between points P and Q. Here, these are 3 cells connected in parallel. We have to find potential difference between P and Q. Now, solution. 1 upon R will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is 1 upon 1 plus 1 upon 2 plus 1 upon 1. LCM is 2. This is 2 plus 1 plus 2 means 5 by 2. Therefore, VPQ will be equal to, potential difference between P and Q will be equal to E1 upon R1 plus E2 upon R2 plus E3 upon R3 whole divided by 1 by R. Now put the values 1 upon 1 plus 2 upon 2 plus 3 upon 1 whole upon 5 by 2. Now this is 2 upon 2 means 1, 1 plus 1 plus 3 means 5 upon 5 by 2. This gives 2 volts. Next question number 8. In the given circuit, find equivalent resistance between points A and B. This is the given circuit. Here all the 4 resistances are connected between points A and B in parallel. Here this resistance A one end, B other end. This resistance B one end, A other end. This resistance B one end, A other end, and this resistance A one end, B other end. So resultant resistance will be 1 upon R AB as 1 upon R plus 1 upon R plus 1 upon R plus 1 upon R, that is 4 upon R. Therefore RAB will be equal to R by 4, because all resistances are in parallel between points A and B. Next question number 9. In the given circuit, find currents in each resistance. Means we have to find the currents I1 and I2 and I3. Solution. At junction A, at junction D, at junction D, KCL gives I1 is equal to I2 plus I3. That is I1 is VA minus VD upon R1. So VA minus VD upon R1 plus is equal to I2 is VD minus VB upon R2 plus I3 is VD minus VC upon R3. That is VA is 70 minus VD upon R1 is 10. VD minus 0 upon 20 plus VD minus 10 upon 30. On simplification we get this gives VD is equal to 40 volts. VD is equal to 40 volts. Therefore I1 will be equal to VA minus VD upon R1 means 70 minus 40 upon 10. 30 upon 10 means 3 ampere. I2 is equal to BD minus BB upon R2. 40 minus 0 upon 20 means 2 ampere. Therefore, I3 will be equal to I1 minus I2 means 3 minus 2 is equal to 1 ampere.